Hello and welcome. This is going to be our homework help video for transformations of the parent function y equals the absolute value of x. Let's start in with this first set of problems. For each equation, state the vertex h comma k and the axis of symmetry x equals. So what we need out of this problem number one is we need an h and a k value. The h is always the value being subtracted away from x. So in this one here, h is equal to 4 and k is equal to 2. So we don't bring the negative with it. We just need that 4. That means that our vertex of this absolute value graph is going to be at 4, 2. Once you know where the vertex is, you know what the axis of symmetry is. You can abbreviate that AOS. It's always just going to be at x equals our h value of 4. So it's always at x equals h. That's going to create that dotted line that this will be symmetrical over. Let's try number 3 here. Now we see a plus here. So the formula already has a minus built in. So what could get us a plus here? Well, that's only if h is negative. So h has to be equal to a negative 4. That way, x minus h becomes x minus a negative 4, and that minus a negative becomes a plus. All right, so that's how we get our h value. K is just the number at the end, so k equals 4. That means our vertex is at negative 4, 4, and axis of symmetry at x equals negative 4. All right, you'll notice that the a value at the beginning has no effect on where the vertex or the axis of symmetry is. That's just there kind of as a distractor in these problems. All we need to focus on are the h and the k. All right, for this next set of problems, we need to describe all of the transformations of the parent function y equals the absolute value of x. Let's get started with number 7 here. So we can see we're adding something directly to the variable. When we do that, that causes a horizontal translation. So I'm going to write it all the way out this time. Horizontal translation of 1, and then we have to figure out if it's left or right. If it's positive, that's always to the left. So 1 to the left. This minus 1 here, that's going to cause a vertical translation. And this one is just a positive moves us up, a negative moves us down. So it's of 1 down. So just for this first one, I'm going to write it all the way out. When you're doing this, I'm okay if you just want to say 1 down for that, 1 to the left for that. Now, a separate arrow going to just the minus in front, the minus of our a value, that's going to cause a vertical flip. And then the 2 causes a separate transformation. That's a vertical stretch of factor 2. So every point is going to get twice as tall off of the y-axis, is how to think of that. So this is exactly what I want your homeworks to look like, with arrows pointing to the different values that are being added into our equation y equals the absolute value of x. So that's where we started, and we added in all this other stuff which causes transformations. All right, let you try the rest of those on your own. Let's now go down to problems 15 through 18 where we need to graph, and we're going to try this without a calculator. So all of those transformations are going to help us out a lot, plus knowing what the parent function y equals the absolute value of x looks like. So first thing I'm going to do on all of these is add in y equals the absolute value of x. This is just to remind me what the general shape of the graph is. In that way, I know where I'm starting when I do those transformations. So this is the graph y equals the absolute value of x. So now where is this graph going to go? Well, it's going to go up 1 because of that plus 1 there. And it's going to go right 2 because of this minus 2 there. So let me take every single point here, move it up 1, and right 2. So I'll start with this point here, up 1, right 2. This point here, up 1, right 2. Up 1, right 2, up 1, right 2, until I get to the vertex, up 1, right 2. Then this point here moves, this point here moves. You'll notice it kept the same shape as our absolute value of x graph. It's just been translated somewhere else onto the coordinate plane. So this is our final graph in blue here, final graph. All right, let's try another one. So let's see, number 18 here. You don't have to move every single point from our parent function. When you do these graphs, the only point that really matters is the vertex. So let's do this one, but only move the vertex and then use our a value to figure out where the other points are going to be. So this one's got an h value of -2, a k value of 2. So our vertex is going to move up 2, and it's going to move left 2. So this is the vertex here. I'll label it from the other side. So that was a left 2 and an up 2. Now from there, I'm going to look at my a value. The a value is causing a vertical flip here because it's negative, and a vertical stretch of 2 because of that 2 there. But I can just use the trick that our a value is the slope going to the left of our vertex to get our next point, which is going to be this point over here. So a slope of -2 from this point down 2/1, lands us there. Down 2/1, down 2/1, gets us the rest of this half. And then I just know that it's symmetrical, so I can fill in the other points pretty easily. So I'm just going to make this point symmetrical over our axis of symmetry, x equals -2. This point symmetrical, make this point symmetrical. And we get our graph. This is the final graph after it has been vertically shifted, horizontally shifted, vertically flipped, and vertically stretched. All right, well, that's it for this video, and have a good rest of your day.